What is up everybody and welcome back to the Maths Guide. Today we have got a Year 7 lesson looking at everything you need to know about number. This is our first lesson in a group of lessons which will eventually cover everything you need to know in Year 7 Maths. In this lesson we're going to cover everything from operations on integers to addition and subtraction word questions, multiplication and division word problems, and then some specific division facts like converting remainders to decimals, before looking at factors and multiples, how to add, subtract, multiply and divide decimal numbers, square and square roots, positive and negative integers, order of operations, prime factorization. Then we're going to look at the distributive law before finally finishing with how to multiply powers of 10 and how to divide powers of 10. So let's waste no more time, let's jump into the first lesson, which is looking at operations on integers. Let's go. Okay, so we can see we have these 4 questions here, and we're going to use a very similar method in every one, and that is we're going to use our place value labels to help us. Well, what does that mean? Well, when we have a number like 34 added to 5,901, we obviously have different amount of digits. So adding a place value chart with our ones, tens, hundreds and thousands in this case is going to make sure we put our digits in the right place. So let's start with 34. 34 is made up of 3 tens and 4 ones, whereas my 5,901 has 5 thousands, 900s, 0 tens and 1 1. Now I can put my equals line, add my addition, and I'm ready to begin. Where do I start? Well, that's right, I start at my smallest value, which in this case is my ones. But before I actually start, what I want to do is look at my question and notice that I have these 2 gaps in my place value chart that I could fill with placeholders, which is not that important for addition questions like this, but will be very important for a subtraction question, which we'll see soon. So starting at my smallest value, I have 4 plus 1 is 5, 3 plus 0 is 3, 0 plus 9 is 9, and 5 plus 0 is still 5. Super simple, easy start. Only thing to remember is to make sure we put the digits in the right place and make sure we include these placeholders. So my answer to 34 plus 5,901 is 5,935. Next question, 6,351, subtract 5,911. Same thing, let's put our column titles, ones, tens, hundreds, and thousands. And now I have 6,351, put everything in the right place. And 5,911 is 5,000s, 900s, 110, 1, put my answer equals sign, my subtraction sign, and I'm ready to begin at my smallest value. This time I have 1 subtract 1, which is 0, in my ones column. 5 subtract 1 is 4. Now, in my hundreds column, I have 3 subtract 9. Well, 3 subtract 9 gives me a negative answer, which I don't want. And I can't just flip these 2 numbers around, which is what a lot of people do, and do 9 subtract 3, because that would give me a whole different question. The question is asking us 3 subtract 9. So what do I have to do? Well, I'm going to borrow from next door, turn this 6 into a 5, and therefore my 3 into a 13. And what I've actually done here is borrowed a whole 1,000 from my 1,000 column and added it to my hundreds. So instead of 300, I now have 1,300s. So now 13 subtract 9 is 4, and 5 subtract my 5 is 0. So my answer is 440. Still pretty easy, let's keep going. With my question, 65 times 436. Put my equals sign, multiplication, ones, tens, and hundreds, and I'm ready to begin. Slightly different for this, I'm going to start with the smallest value on my bottom number, which is this 6. And basically I'm going to be multiplying the 6 by 65, then I'll multiply the 3 by 65, and then the 4 by 65. But let's see how that works. Starting with my 6. I'll start with the smallest value on the top line as well, and I'll do 6 multiplied by 5. 6 times 5 is 30. 30 is a 3 and a 0. Then I'm going to do 6 times 6. 6 times 6 is 36, plus my 3, 39. Now I'm ready to do the 3, but this is not a 3, it's a 30. So to get a 30, which is 10 times larger than 3, so to get my answer to be 10 times larger, I'm going to put a 0 or a placeholder in my ones column. That means I can just look at that 3 as a 3 instead of a 30. 3 times 5 is 15, 3 times 6 is 18, plus my 1, 19.
Let's get rid of these little numbers so we don't mess up them later. And last but not least, I have a 4, which is actually a 400. So I'm going to put 2 placeholders in to show that this answer is 100 times larger. 4 times 5 is 20, and 4 times 6 is 24, plus my 2, 26. Get rid of that little number, and I'm ready now to add my number back together, because what I've done is just individually multiply all the little parts. Now I'm going to get my final answer. In my ones column I have a 0, a 0 and a 0, that gives me 0. In my tens I have a 9 and a 5, it gives me 14. In my hundreds I have a 3 and a 9, which is 12, plus my 1, 13. In my thousands I have a 1, a 6 and this new one, which is 8, and a 2 in the 10,000s. So my answer, 28,340. Right, let's tackle our last question. So we're going to have 456 divided by 11. Now I'm going to be using a different method this time. This is called the bus stop method. And all I'm going to be doing is looking at how many 11s there are in the 4, the 5, and then the 6 with whatever's left over. Let's see what that looks like. And it might help me in this case to write out the 11 times table so I can see what that would look like. And it's 11, 22, 33, 44, 55, 66, 77. Hopefully that'll be enough. So how many 11s do we have in 4? Well, if I have a group of 4 oranges, I can't take a group of 11 away. So I have 0. But I'm going to carry that 4 across into the next column. Now my next question says how many 11s in 45? Well, I can get 1, 2, 3, 4. That only gets me to 44, so I'm going to put 4 up here. How many is different between 44 and 45? There's 1. How many 11s are there in 16? There is 1. How many left over between my 11 and the 16? There would be 5, so I can put the remainder 5. Or if I wanted to be super smart, let's rewrite it up here so I've got a bit more space. So instead of putting my remainder 5, what I can do is get into my decimals by putting a decimal and then 0. Because don't forget that 0 is not going to change the value of my answer, but it gives me somewhere to put my 5. How many 11s in 50? Well, there's 4. How many left over? 6. Add another 0. Again, the 0 doesn't change the value. How many 11s in 60? There is 5. How many left over? 5. And I can see that we're going to get this same pattern all the way, so it's going to be 4, 5, 4, 5, 4, 5, or in other words, 45 recurring. Don't forget to bring up my decimal. So my answer as a decimal would be 41.45 recurring. Easy. Now it's your turn. Have a go at these 4 questions, one of each operation. Press pause on the video now. When you've got an answer, put your answer in the comment section. Press pause. Good luck.
Okay, so now we've done that, we're going to look at some adding and subtracting word problems.
So what do we need to remember today? Well, we need to remember we're going to use the rucksack method to help us. So what does rucksack mean? Well, rucksack is R-U-C-S-A-C. And each of these letters represent a word. R is read, U is underline, C is choose, S is solve, A is answer, and C is check. So let's use these words now to help us solve this 2-step word problem. And the first thing I need to do is read. So let's read this question now. Lily is a sticker collector with a magical sticker album. She starts with 735 stickers. One day she gives 268 enchanted stickers to her best friend Mia. Later, while exploring a hidden treasure chest, she discovers 189 rare stickers and adds them to her collection. How many does she have now? So we've read it, well done. Now we're going to underline. But what does that mean? We're going to just underline everything? No, we're going to underline the important information. Important information is going to be any numbers we need to use and any words that try and help us understand which operation we're going to use to solve, whether it's going to be addition, subtraction, multiplication, or division. So let's get underlining. Lily is a sticker collector with a magical sticker album. She starts with 735 stickers. One day she gives, well, gives tells me something, doesn't it? 268 enchanted stickers to her best friend Mia. Later, now this kind of tells me something as well. It sort of implies that we're going to be doing another question. Later, while exploring a hidden treasure chest, she discovers 189 rare stickers and adds them to her collection. How many does she have now? Well, I think that last part is all important because it tells us that we need a total answer. Now my next part says choose. Choose means which operation are we going to use? Well, if I look now just at my highlighted information, we have 735 and she gives 268. Well, gives to me suggests that we're going to be subtracting. So I put that little mark there. Later, while exploring a hidden treasure chest, she discovers 189 rare stickers and adds them, nice and simple, to her collection. How many does she have now? So we have a subtraction and we have an add. So I think we're going to be having a two-step problem. Now I need to solve. Solve simply means we're going to write out these number sentences. So the first one is 735, and then I'm subtracting 268. And that's going to leave me with an answer. But it says later, while exploring hidden treasure chests, she discovers 189 rare stickers and adds them to her collection. So we have the next number sentence is going to be the original answer, which was just here. So I'm going to have my answer and I'm going to be adding it to this new 189 stickers. And that's going to leave me with the total. Now I can do the next part, which says I'm going to answer these number sentences. So I'm going to use a little bit of spare paper over here. 735, subtract 268, put my answer line, and I'm subtracting. 5 subtract 8 I can't do, borrow from next door. 15 subtract 8 is 7. 2 subtract 6 can't do, borrow from next door. 12 subtract 6 is 6. 6 subtract 2 is 4. So my answer for the top row is 467. Now I can replace this answer with 467, which means I can also replace the first part of this number sentence with 467. Now I'm adding 467 to 189. Add them up. 7 plus 9 is 16. 1 plus 6 is 7, plus 8 is 15. 1 plus 4 is 5, plus my 1 is 6. So my total is 656. And now the last thing I need to do is just check my answer. Well, there's loads of ways that I can check. I can check by giving this to you, let you check it for me, or I can give it to my teacher or my family, or I could try and think about a mathematical way of checking, which could be to use the inverse operations to check my answer. So I could get 656 and I could subtract now 189 and see if I still get 467. But in this case, I'm not going to do that. I'm going to check by checking the original numbers. Again, another important thing to check. I started with 735 and I put 735 here. One day she gives, so subtract 268, and that left us with 467. Then I had 467 add, just there, to my 189, just there, leaving me a total of 656. Good checking. And I've got a total answer of 656, job done. And I did that by using my rucksack method. Now let's look at a harder challenge. And again, I'm going to use my rucksack. So R-U-C-S-A-C, read. So read, first of all. Sophie's saving up for a new book. She has £23.75 in her piggy bank, but she spends £8.49 on a gift for her friend. Later, she earns £12.60 from helping her parents with chores. How much does Sophie have now? Blimey, how much is this book? Anyway, then we need to underline the key information. Now remember, key information is numbers and anything that's going to help us understand which process to use. So we have £23.75, but then she says she spends £8.49 on a gift for her friend. Later, she earns £12.60 from helping her parents. How much does Sophie have now? Now I just need to choose my operations, and I think we have £23.75, but she spends, sounds like subtraction, £8.49 on a gift for her friend. Later she earns, that sounds like addition, £12.60 for helping her parents with chores. Now I'm going to solve, and if you remember, solve just means to write out my number sentences. So I had £23.75, subtract £8.49. That's going to leave me with an answer, and then that answer is going to be added to £12.60 to give my total. There we go, I've solved. Now I need to actually get the answer, and I'm going to use my column methods to do it, starting with £23.75 added to £8.49, making sure I keep my decimals in line so I know I don't make a mistake. Here we go. 5 plus 9 is 14. 7 plus 4 is 11. Plus my 1 is 12. Put back my decimal, that's very important. 1 plus 3 is 4. Plus my 8 is 12. And 2 plus my new 1 is 3. So my answer should be £32.24. Now I can replace that answer and this answer with 32.24. But now I need to add that 32.24 to 12.60 to get my total. 4 plus 0 is 4. 2 plus 6 is 8. Put back my decimal. 2 plus 2 is 4. 3 plus 1 is also 4. So my total of how much Sophie has right now is £44.84. £44.84. Now I can check, and this time I'm going to check by asking you to go through this yourself. See if you get the same answer as me, and then we can check my work. Once you've done that, it's your actual turn. Here is a question for you. Write out rucksack and solve it step by step. I will do the first part for you by reading it to you. Oliver is planning a day out. He starts with £50 and 25 pence in his wallet. He buys a ticket to the zoo for £17.80. Later he finds £6.45 in his coat pocket that he had forgotten about. How much money does Oliver have now? Use the rest of the rucksack to solve this question. Press pause on the video now. Good luck.
Okay, now we've mastered adding and subtracting word problems, let's have a little go at some multiplication ones.
So let's start by following the steps of our rucksack by reading our question. A stadium sells 320 tickets for one concert. Each ticket costs £25. The stadium runs 4 concerts a week. The total income for the week is reduced by £300 a day for staff costs. Question: how much money does the stadium make after staff costs? Okay, let's see what we're going to need to do. My next step says underline. Well, what does this mean? It means underline the key information. So let's start. The stadium sells 320 tickets for one concert. That's quite important. Each ticket is £25. That's quite important. The stadium runs 4 concerts a week, and the total income for the week is reduced by £300 a day for staff costs. How much money does the stadium make after staff costs? Okay, we've underlined our key information. Now we're going to choose. Well, what does choose mean? It means to choose the operation you're going to use to help you get the answer. So the stadium sells 320 tickets and each ticket costs £25. Well, if we have 320 and each of them is £25, I think we're going to be using multiplication here. So I'm going to put a little multiplication sign to remember. The stadium runs 4 concerts in a week. So again, we're going to use multiplication here to times it by 4. And the total income for the week is reduced by £300 a day. So we're going to be using subtraction, but also a little bit of multiplication or addition here because we've got £300 a day and there's 4 days. So we're making a few notes as we're going along as well. Then it says to solve. Well, what does it mean to solve? Solve means to create your number sentences. So let's begin with 320 multiplied by 25. That's going to give us an answer. And then we're going to get that answer and we're going to multiply it by 4. That's going to give us our total. And then we need to get our total and we're going to subtract it by the £300, but there's 4 lots of the £300 because it's a 4-day concert, and that's going to give us our total answer. Now we're going to answer, and answer means simply start solving it. So 320 times 25, we could use our written method over here, but I'm going to cheat because I can actually do that in my head, and I know the answer is 8,000, but if you don't know the answer in your head, please make sure you use the right written method. So our answer is now replaced by 8,000, so I can put 8,000 at the front here as well. Now, my next line says 8,000 times 4, and 8,000 times 4 is 32,000. So my new total is 32,000. But now I'm subtracting it by 4 lots of 300. And 4 lots of 300 is 1,200. So my last thing to answer is 32,000, subtract 1,200. And the answer, my total answer, is 30,800. Simple. The last thing I need to do is check. And there's lots of different ways that we can check. We could check it with a teacher or a parent, or we could go back through the whole thing and just go through it one more time, make sure we've not made any simple mistakes. We could potentially do the inverse of some of these operations, or we could ask someone else to check it for us. And that's what I'm going to ask you to do. I would like you to check this question again and make sure I've not made any silly mistakes. So go through it step by step and see if you get the same answer as me. When you've done that, now it's your turn. Here's another question that I want you to use the rucksack method to help solve. I'll read it to you first. A factory produces 145 items every day. Each item sells for £12 and the factory works 6 days a week. In 1 week, 35 items are returned and refunded. Question, how much money does the factory make that week after the refund? So a similar sort of style question, so have a go at this yourself. Press pause on the video now, good luck.
Now we've done 3 of the 4 operations, let's finally finish with some division word problems. Let's go.
R says read. Well, let's read the question. A factory produces 1,248 toy cars in 6 days. A box can hold 12 toy cars. If the factory produces the same number of cars each day, how many boxes can be packed in 1 day? Okay, now we need to underline the key information. Well, that's going to be numbers and things that help us understand whether it's going to be addition, subtraction, multiplication or division. So a factory produces 1,248 toy cars in 6 days. A box can hold 12 toys. If the factory produces the same number of cars each day, how many boxes can be packed in 1 day? Okay, so there's our key information. Now we're going to choose. What operation do we need to use? Well, first of all, I can see that we need 1 day. So at the moment, we've been told the factory produces 1,248 toy cars in 6 days. So I think we're going to need to divide our number here to get down to 1 day. But then we're also going to need to do another division because a box can hold 12 cars and we want to know how many boxes it is, not how many toy cars it is. So we're going to need to do another division just here to find out how many boxes it is. So now I've chosen, now we're going to solve. Solve means to write out my number sentence. So our first number sentence is going to be 1,248 divided by the 6 days. That's going to give me an answer. Then I'm going to use that answer and divide it again by 12, which is the amount of cars that can go in a box, and that's going to give me my total. So now I've solved it, let's actually answer it. And I'm going to use my bus stop method over here, 1,248 divided by 6. How many 6s are there in 1? Well, I can't do that. How many 6s therefore in 12? There'll be 2. How many 6s are there in 4? Can't do that. How many 6s in 48? There are 8. So my answer can now be replaced with 208. Therefore, this answer is also 208. So that's how many cars are produced in a day, but we need to know how many boxes that will be, and each box is 12 cars. So my final question is 208 divided by 12. Well, how many 12s are there in 2? Can't do that. Carry the 2 across. How many 12s in 20? 1 with 8 left over. And my last part says how many 12s are there in 88? Well, let's go open our 12 times table. 12, 24, 36, 48, 60, 72, 84, 96. So I can get 1, 2, 3, 4, 5, 6, 7, but I'm going to be left with a difference between the 84 and 88, which would be a remainder of 4. Or in other words, my answer would be how many boxes can be packed in 1 day? 17 whole, or 18 if I need to pack those extra 4. So I'm going to give an answer of 17 whole boxes. Now the last thing to do is check. And when I check an answer, I can do lots of different things. I can go through it again and meticulously make sure I did everything correct. Or I could ask a teacher to check it. I could ask a friend to check it. Or in this case, I'm going to ask you to check it. Take some time and work through this question again and see if I made any mistakes. Maybe I did. When you've done that, I've got a question for you yourself. Here's another question. Your turn. A school library has 2,310 books. They are arranged evenly on 7 shelves, and each box can hold 15 books. If all the books on one shelf are packed into boxes, how many boxes will be needed for that shelf? Pretty complicated. Let's use our rucksack again to solve it. Press pause on the video now, take your time and see if you can get a good answer in the comment section. Press pause, good luck.
Okay, now I want to have a look at a very important skill when we're looking at division. Let's look at how we can convert a remainder into a decimal. This is very important for year 7. Okay, so we have these 3 questions. We have this green chili, the orange chili, and the red chili challenge. And we have something to remember. We need to remember today that adding a decimal and zeros after the decimal do not change the value of that number. So let's see what I mean by that with this first example, 726 divided by 5. So the first thing we're going to do, just like normal, is put our numbers into the bus stop. So we have the dividend of 726, in it goes, and then we have the divisor of 5. So we have got 726 something, and we are dividing them between 5. Now my first step is just to go, how many 5s are there in 7? Well, I have 1 with 2 left over. So my next question is how many 5s in 22? And I have 4 with 2 left over. And I'm rushing through this little part here. If you don't really understand how to do short division, then go and look at the proper video that covers everything you need to know about short division. Today we're specifically looking at the remainder part. And then how many 5s are there in 26? I have 5. Now traditionally what we might do is put our little remainder 1 just like that at the end of our answer. But today we're going to look at what to do if we want to turn it into a decimal. So let's get rid of the remainder 1, but we need somewhere to put it. Well, if we look back to what to remember today, adding decimals and zeros after our number doesn't change the value. So let's do that. Let's put a decimal point in place, and if I'm going to do it on the question row, I need to do it on the answer row as well. And then I'm going to put a 0 after that. Now I have somewhere that I can carry my remainder 1 over to, because now when I move my 1 over there, my next question says how many 5s are there in 10? And there are 2 5s in 10. So my final answer, making sure that I put my decimal point in place, is 145.2. Let's look at that again with an orange chili challenge of 455 divided by 4. First question, how many 4s are there in 4? Well, there's 1 with nothing left over. How many 4s in 5? There's 1 with 1 left over. And then how many 4s are there in 15? Well, I can get to 4, 8, 12. So I have 3, but I also have 3 left over. So what do? That's right, put my decimal point in place and add a 0 in the 10ths column. Remembering that does not change the value of my 455, because 455 is exactly the same as saying 455.0. But it means I have somewhere now that I can put my 3 that was left over. So now my next question says, how many 4s are there in 30? Well, 4, 8, 12, 16, 20, 24, 28. I get to 7, and I mustn't forget to put my decimal on the answer row as well. But again, I had some left over. This time I had 2 left over. So I can actually add another 0 into my hundredths column. And again, that doesn't change the value, so I'm not doing anything wrong. Carry my 2 across, leaving my last question. How many 4s are there in 20? And there are 5. So my answer is 113.75. Or in other words, 113 75 100ths. Okay, but let's have a look if things get a bit weird. Let's have a look at this red chili challenge, which might look super easy because we've got really small numbers, but watch what happens in this example. So I have 8 divided by 6. So my dividend is 8, my divisor is 6. Let's begin. How many 6s are there in 8? Well, there's 1, and we have 2 left over. So I need to put my decimal in place, put my 0, and carry my 2 across. How many 6s are there in 20? 6, 12, 18. I have 3, and I have 2 left over. So I need to put another 0 and another 2. But look what's happening. All that's happening here is I'm getting into this weird pattern of only being able to get up to 18 and constantly having 2 left over. So my answer is actually going to be 1.333333333 forever and ever and ever. But I don't want to do that. So all we have to do in this case, if we get into a pattern like this, where we see the same number repeated, or in some cases the same pattern repeated, we might see 5, 3, 5, 3, 5, 3. But in this case we have just 3, 3, 3, 3, 3. All I have to do is do a couple of them and then put dots above to show that they're occurring. So not too tricky, but definitely something a bit weird. Now it's your turn. Have I got these 3 questions here? I've got a green, an orange and a red chili challenge for you.
Put your answers in the comment section. I'm going to try and mark every single one.
Okay, now we've sort of worked with our 4 operations, let's have a little look at some factors and multiples. Okay, so multiples and factors. This is something we really want to understand well before moving too far into multiplication, because these are really essential elements. So let's have a look what they mean. So we have 2 numbers here we're going to work on. We have 6 and we have 36. Okay, so we're going to look for the multiples and the factors of both of these numbers. So let's do one at a time. Let's have a look at 6 first of all, and let's look at our understanding phase. So what does a multiple mean? Well, a multiple means the product of the number that we're looking at, which in this case is 6, times by any integer. And an integer just means a whole number. So there's a logical sequence to this, isn't there? We can do 1 times 6 equals 6. So there's our first multiple. Then we could do 2 times 6 equals 12. So 12 would be a multiple. 3 times 6 is 18, 4 times 6 is 24. So all of these numbers here, our 6, 12, 18, 24, and every other number that would come after this when multiplying by other integers are all multiples of 6. So you're essentially saying what numbers would be in the 6 times table: 6, 12, 18, 24, 30, 36, etc, etc. Now you can have negative multiples, but we're not going to look at that in this video. We're going to look at positive numbers in this video, but just so you know, you can go backwards and have negative numbers too. So multiples is just the product of the integer multiplied by your target number, in this case 6. So what are factors? Well, factors are pairs of numbers that equal our target number. So again, in this case, we're looking at 6. Our product wants to be 6, so we need 2 integers that are going to equal 6. And again, there's a bit of a logical sequence to this, because we can always have 1 times the number itself, which in this case is 6. 1 times 6 will be 6. So therefore, we can always have the number itself multiplied by 1. They're always going to be our first factors. So then, carrying on the logical sequence, I've just done 1 times 6. Now I want to try and see if I can do 2 times something. So can I multiply 2 by anything to get 6? Well, yes, I can multiply it by 3. 2 times 3 is 6. And now here's a little trick, because look, if I try and do 3 times something, well, the only thing I can do is multiply it by 2, and that's still going to equal 6. But I've already used these numbers, these integers, in the previous question. So when we get to a number that we've already used, in this case 3, we know that's as far as we can go with finding our factors. So this one here, we don't need. So now we can look at these numbers, 1, 6, 2, and 3, and register that they are the factors of 6. So 6 has factors 1, 6, 2, and 3. So it has 4 factors, or 2 factor pairs. Good. Okay, let's have a look at a difficult one. Let's have a look at 36. So this one immediately is much harder when we're looking at the multiples, because how do I work out the multiples of 36? Well, I can simply just keep adding 36 if I wanted to. So here we go. 1 times 36 equals 36. So multiples are just the times table, the 36 times table. So now I can look at 2 times 36, and that's going to equal 72. But that's about as far as my mental maths wants to go. So now I can just keep adding 36 to my answer. So if I add 36 to 72, I'm going to get 108. So therefore that would be 3 times 36 and another multiple of 36. Let's do one more. So if we add 36 to this, 8 add 6 is 14, 0 add 3, add the 1 is 4, 1 add nothing is 1, so 144. So 4 times 36 is 144. So some multiples of 36 would be 36, 72, 108, and 144. And this could go on indefinitely for as long as there are integers. I could do 10,153,622,112 times 36, That's going to give me an answer, and that is a multiple of 36. So we could go on forever. And don't forget negatively as well. Okay, so what are my factors of 36? Well, I'm going to think about that logical sequence again. I'm going to start with my 1. 1 times 36. And I've got 2 factors straight away. Now I'm going to check to see if there's a 2 times anything. And I can see that there's 2 times 18. And I'm still going to try and carry on this sequence. So now I'll try and do 3 times something. Now my mental maths might not be strong enough to get me there, so I can now look at the inverse if I want to do. What's 36 divided by 3? Well, 36 divided by 3 is 12. So therefore 3 times 12 would give me 36. Okay, let's have a look at the next logical one. I'm going to check 4. Can I make anything with 4? 4 times something equals 36. 36 divided by 4 is 9. Wow, okay, I've got another one. Okay. Let's check 5. 5 times something equals 36, or 36 divided by 5. No, I don't think it does. Let's check by going up in our 5 times table. 5, 10, 15, 20, 25, 30, 35, close but not quite, and 40. So no, 5 doesn't work, and that's okay. I can just get rid of it. Okay, let's move on though. So let's check 6, because remember, just because it didn't work with 5 doesn't mean that's the end of it. So 6. Is there anything that I can times 6 by to get to 36? Well, yeah, I can times 6 by itself, 6. 6 times 6 is 36. Okay, let's check 7. 7 times something equals 36. 7, 14, 21, 28, 35. No, again, can't get there. So we get rid of 7. And let's check 8. 8, 16, 24, 32, 40. No, 8 doesn't work either. And therefore, my next number would be 9, but I've already got a 9, so I now know I don't need to do that one, and I've come to the end of checking my factors. So, how many factors does 36 have? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? No, because we've already got a 6 here, so we don't need to include this other 6. So if we're talking about how many factors 36 has, it has 10. Okay, so let's quickly think about what the difference is again between these two words, the multiples or the factors. Multiples are simply numbers that would come in that times table if we're going to just keep multiplying it by an integer. Okay, hope this has been useful for you. I've now got a couple of questions for yourself to have a look at. I've got the number 42 and the number 18. I'd like you to give me 5 multiples for each of them and all of their factors. When you do that, put it in the comment section and I'm going to try and mark every single one. So press pause now, guys, have a go at doing that, and I'll see you in a minute.
Okay, great. Now we're going to have a little look at how we can add, subtract, multiply and divide decimal numbers. Let's go.
And let's start with the addition question. We have 34.5 added to 5.901. And what we're going to need to remember today is to use our place value chart to help us so that we don't make any small mistakes. So with that in mind, let's have a look at our numbers and decide what titles we're going to have to include. And I can see that we've got tenths, hundredths and thousandths in this second number. So let's start with thousandths, then hundredths, tenths, put my decimal back, ones, tens, hundreds, and let's see if that's enough. Now I'm going to put my numbers in place. I have 34.5, 34 is 3 tens, 4 ones, decimal place 5 tenths, added to 5 ones, decimal place 9 tenths, 0 hundredths and 1 thousandths. But now I have these gaps in my question, 3 of them, that I can fill with placeholders, which isn't as important in addition, but it's very important in subtraction. So let's get into a good habit and do that now. Put my equals line, and I'm ready to begin adding up. Start at my smallest value, which is the thousandths. 0 plus 1 is 1, 0 plus 0 is 0, 5 and 9 is 14, carry the 1 across into the ones column, put my 4 in my tenths column, put back my decimal, add the 4 to the 5, gets me 9, add the new 1 that we have in there, gets me 10, same thing again, 1 into the tens column, 0 into the ones, and then 3 added to my new 1 gives me 4. So my answer is 40.401. I'm going to put that just here, 40.401. Great, now let's try and tackle my subtraction question with the same principle. And again, I'm going to have thousandths, hundreds, tenths, my decimal, ones, tens. I'm going to put hundreds. And I'm going to start with my 63.51, has 6 tens, 3 ones, my decimal, 5 tenths, 1 100th. And then I'm subtracting 5.901, so it's 5 ones, decimal place, 9 tenths, 0 hundredths, and 1 thousandths. But now again, I have these gaps in my question, and now it's super important to put my placeholders, because if I don't put a placeholder, I could make a very serious mistake, which we'll talk about in a moment. Put my equals line, and I'm ready to start subtracting. Now, start at my smallest value, 0, subtract 1. I know this placeholder we've only just put here, but it's very important. If I didn't have that there, I might be inclined to just put a 1 here in my thousandths answer, but that would not be correct. Let's see. If I have 0, what it means is I actually cannot take 1 away from 0, so I have to look next door, and I can see I have a 1 in my hundredths column, which I'm going to borrow and give to my thousandth, making that 10 in my thousandths column. Now I have 10 subtract 1 equals 9, which is very different to the 1 I would have had if I didn't put the placeholder there. Now I have a 0 in this hundredths column, so 0 subtract 0 is 0. 5 subtract 9 I can't do, so I have to borrow from the next available digit, which is the 3. 15 subtract 9 is 6, put back my decimal. 2 subtract 5 I can't do, borrow from next door. 12 subtract 5 is 7, 5 subtract 0 is 5. So my answer to 63.51 subtract 5.901 is 57.609, or 57 and 609 thousandths. Okay, next question I have on multiplication, and I have 6.5 multiplied by 43.6. And the little trick when I'm doing multiplication with decimals is I'm actually just going to ignore these decimals for now. So get rid of them, 1, 2, and I'm going to do it like a normal multiplication question using my column method, starting with my smallest value. 6 times 5 is 30, 6 times 6 is 36, plus my 3, 39, 39. I've got no other question to answer on that top row, so I can just put the 39 in as it is. So the answer to 6 times 65 is 390. Now I'm going to do 3 times 65, but it's not a 3, it's a 30, so I'm going to put my placeholder in place, and I can just do 3 times 5 is 15, and 3 times 6 is 18, plus my 1 is 19. Get rid of that little 1 so I don't add it at the end. And then the last row is actually not just a 4, it's a 400, so I need to put 2 placeholders to show this is 100 times bigger. 4 times 5 is 20, and 4 times 6 is 24, plus my 2, 26. Now I just need to add this all up, and I have 0, 0, and 0 is 0. 9 plus 5 is 14. 3 plus 9 is 12, plus my 1 is 13. 1 plus 6 is 7, plus my 1 is 8. And 2 on its own is 2. So my answer is 28,340, but not quite, because don't forget I ignored 2 decimals. And the little trick to remember where to put the new decimal place is, how many digits after the decimal did we ignore? Well, we ignored 1 here and 1 here. So my decimal at the moment is just here at the end, and I have to move it 2 places, 1, 2. So my answer is 283.40, or just 0.4. And last but not least, the division question. I have 45.6 divided by 4. This looks really hard, but it's super simple. All I have to do, how many 4s are there in my 4? I have 1. How many 4s are there in my 5? I have 1, but I then have 1 remainder, which I'll bring over here. How many 4s are in my 16? Well, there is 4. Carry the decimal up, and my answer is 11.4. And there you go. That is how to use the 4 processes, or the 4 operations in mathematics with decimal numbers. But before you go, have a go at answering these 4 questions yourself to see if you've understood it. Take some time, press pause on the video now, and put your answers in the comment section. Press pause now. Good luck.
Awesome, now we're going to start to get into some more tricky elements. Let's have a look at a square and square roots and what they mean.
Okay, so when we are squaring a number, which means it's got this little 2 up here just hovering in space that we can call a power, or the exponent, what it means is we are getting our 4 and we are multiplying it by itself 2 times. So we have 4 multiplied by 4. And 4 multiplied by 4 is 16. So the answer to 4 squared equals 16. And square root is basically the opposite. It means our answer is 25. So we have the square root here of 25. It means our answer is 25. And what it's asking us is what 2 numbers that have to be the same can we multiply to each other to get the answer 25? Well, let's have a little experiment. 1 times 1 would be 1. So that's not it. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. So I think we've found it with our 5 times 5. So the square root of 25 equals 5. Or in other words, 5 squared is 25. But what does it even mean, and why do we call it squaring? Well, if we look at this grid, 4 squared essentially means that we are coming up to the positive 4 on the y-axis and across to positive 4 on the x-axis. And when I link those two together, we can see that we have made this square. And if we count all the individual squares inside the square, we will get 16, because we've got 4 multiplied by 4. 4 multiplied by 4 is 16, as we learnt. And therefore with 25, what I'm basically doing is I'm building a square out of 25 little squares. So I'd have 1 there, 2, 3, 4, 5, 6, 7, 8, 9. Still keeping it a square shape. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now when I create that shape, we can see that it joins the 5's together. Therefore the square root of 25 equals 5. However, there is a little bit of a caveat here, because there is also a different answer to the answer of square root of 25 equals 5. And we could also make a square on this grid with 25 little squares, which uses the same number on the x and the y axis. Well, let's try it in this quadrant over here. If I built my square just here, I would have 5 on my x and negative 5 on my y, so it can't be this square. Over here, in this quadrant, would be 5 on my y, negative 5 on my x, so it can't be this one. But if I build a square over here on the negative quadrant, then on my y-axis I have negative 5, and on my x-axis I have negative 5. So the square root of 25 could also equal negative 5. Just a little caveat there for you to think about. But that's essentially it. That is what squaring and square rooting means. Have a little practice yourself at squaring some numbers and then try and find the square root of them.
Okay, well done. We're getting really through the hump of the lesson. Let's have a little look now at positive and negative integers and what that means. Let's go.
Okay, what do we need to remember? We need to remember that a number line is infinite in both directions. Well, what does infinite mean? Infinite means it can go on forever. So there's no end to the numbers. We could just keep writing bigger and bigger numbers in both directions. So what does that mean? Well, if we're starting from our number 0 here, everything to the right along our number line we call positive numbers. And here we only have 1, 2, 3, 4, 5, 6, 7, 8. But what I'm saying is we could go on forever. We could end up with numbers as big as this. And I can't even say this number that I've just written on the screen. But we could go on forever. So what are negative numbers? Well, negative numbers are just on the other side of the 0. So if we call this group our positive numbers, these then become our negative numbers. And just as a matter of fact, 0 is called the origin. Almost like saying the start. So what is a negative number, and when might you see it? Well, let's imagine that I have £5. So I would find my £5 on the number line. There it is. But let's say, oh no, I owe my mum £10. That means I owe her, so I'm going to have to subtract £10. So if I had to give my mum £10, I would come back down my number line. So I'd come 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I would actually end up having minus £5. Or in other words, negative 5. Let's look at another example. Let's imagine I have negative 7. I've already got a debt. I owe something. So I have minus 7. But let's say someone gives me, so I add £10. Now because I'm adding, I'm going to come up my number line. So I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I would land on 3. So I would actually end up finishing with a positive 3. And when we're talking about positives, we don't need to put the plus in front of it. If it's a number on its own, we just know it's positive. So when might else we see negative numbers? Well, what about the weather? Now, if you live in the UK, currently as I'm recording this, it's February the 9th, and I know, because my brother lives there, that it's snowing in the north of England, and the temperature is negative 4. But where my mum and dad live, it's positive 3. And 0, the origin, is the mark for freezing. So on a thermometer, my mum and dad's house would show 3 degrees, but my brother's house would show minus 4 degrees, colder than freezing. Let's do one more example. Let's say I started already owing. I owe 2, so I'm on negative 2. Now this time, let's imagine I have to give more away, so I'm going to subtract 5. Which way along my number line am I going to go this time? Well, because I'm having to subtract 5, I'm not going to be getting more would be coming up my number line. I'm going to be getting less, which is to the left of my number line. So if I'm on negative 2 now, and I need to take 5 away, I'm going to make 5 jumps, 1, 2, 3, 4, 5. And I would end up with negative 7. So what do we need to remember about negative numbers? Well, we need to remember that both positive and negative numbers can go on forever. We also need to remember that 0 is kind of like saying the start. It's the origin. So it's neither positive nor negative. And then the numbers directly to the right and left of the origin are 1 and minus 1, and they're going to go up in sequence, but to the right is positive and down to the left is negative. And we also need to remember that we can get into debt with numbers. I can owe an amount. So here's a little activity for you. Can you work out the green, orange and red chili challenge? Use the number line on the screen to help you. Press pause on the video now. Good luck.
Excellent. Now we're going to have a look at one of the laws, and that is the law of operations, or the order of operations. Let's go. Okay, so what is the order of operations? Well, the order of operations is a mathematical principle, meaning the order that we need to do operations within a mathematical question. And we have this little term BODMAS to try and help us remember what order that is in. So let's have a look, and let's have a look at this question that we've got in the middle of the screen here. So our starting point would be here with the B, and our B stands for brackets. So the first thing we would have to work out in any question, if there is it, would be a bracket. Then our O stands for order, which is this little power of 2 here next to the brackets. And then the D stands for division. Our M is multiplication. Our A is addition. And our S stands for subtraction. But in this case, we don't have any subtraction, but that would come last. Now, in some instances, you might see BIDMAS down here, where the I and the O are different. And in BIDMAS, it just means index. Same principle, it still means this power of 2 here, but it's just taught differently in different places. So BODMAS, BIDMAS, exactly the same thing. Okay, so let's follow our order of operations and try and solve this question then. So our first order is brackets. So we're going to solve the question in the brackets first. And in my brackets, I can see 12 divided by 3. Now, some of you might have noticed that our power of is connected to the brackets. But because it's not in the bracket, we're not going to do that at this stage. So I'm going to rewrite my next line, and it would be 4
plus, now I can solve the brackets. So 12 divided by 3 is 4. And because now 4 is the only thing inside the bracket, I can actually now get rid of my brackets. It'll be 4 to the power of 2 multiplied by 2. Okay, the next thing to do is the order, which in this case is this power of 2 here. So 4 to the power of 2 is just 4 multiplied by itself, so 4 times 4, and 4 times 4 is 16. So my next row would read 4 plus 16 times 2. My next one says division, and we actually don't have any more division in this question left, so I can move on to my multiplication. And my multiplication is this part here, 16 times 2. And the answer to 16 times 2 is 32. So my next row would be 4 plus 32. And I can now do my addition, and that's our last question actually. So I can now do 4 plus 32, and 4 plus 32 equals 36. So my total answer for this expression is 36. Okay, let's look at a harder one then. Let's look at this one here. And what's important to bring up now is that our division and multiplication and our addition and subtraction are linked. So although it says that our division will come before our multiplication and our addition should come before our subtraction, actually the case would be that if we get to a division or multiplication part, we would do it in the order that it's written. So if we were to look at this stage here, 4 divided by 2 times 3, I would actually start with my 4 divided by 2 because that's the first in the sequence. But if it read 4 times 2 divided by 5, then I would actually start with my multiplication because that's first in the sequence. So my division and multiplication are linked, and so is my addition and subtraction. So with that in mind, let's begin. And I'm going to start with this bracket first of all. Now in this bracket, I can already see that I have an order up here. So I'm going to do that part of the bracket first. So now my bracket would read 2 times 2, which is 4, plus 3 times 4 to the power of 2. Okay, looking back at my first bracket, there's no division in this question, so I can move to the multiplication. 3 times 4, which is 12. So I've got 4 plus 12 to the power of 2. Now within this bracket, I can finish off with my addition. And 4 plus 12 is 16, so it'll be 16 to the power of 2. And because 16 is on its own, I can actually get rid of that bracket, and I can simply work out 16 squared. And 16 times 16 is actually 256. So I'd end up with 256. Now I can move on to my other bracket, and I can see that in this bracket I'm going to have to work out the division first, which would be 4 divided by 2, which is 2. So I'd end up with 256 divided by 2 times 5 plus 2. And now in my next row I'm going to do the multiplication of this bracket, which is 2 times 5. So I'm ending up with 256 divided by 10. And now I've got rid of the bracket. And now I can see my question says 256 divided by 10 plus 2. And I'm going to have to work out the division first because that's first in my BODMAS before the addition. So I can do 256 divided by 10, which would be 25.6. And I'd have my plus 2. Now I'm ready for my final line where I can solve the final part, the addition, and 25.6 plus 2 equals 27.6, which is my final answer. So the final answer to this expression is 27.6, following my BODMAS rule. Okay, some things to remember then. So BODMAS can also be called BIDMAS. You might see it like that in some expressions, depending on whether we call it order or index. We must work in this order when solving any expressions. And then finally the addition and subtraction, and then the multiplication and division, they are actually paired, and we would do those in the sequence that they appear in from left to right.
Okay, we're getting into some tricky concepts, aren't we? Let's have a look at another tricky concept, prime factorization. You're going to need your math head on for this. Let's go.
So first of all, we need to understand that factors are numbers that multiply together to equal the original number. So we know what factors are, but what does it mean by prime? What's a prime number? Well, let's have a look at this number 20. And if I'm trying to find the factors of 20, I can draw my factor tree, and I can see that 1 times 20 would equal 20. So 1 and 20 are both factors. I can also see that 2 and 10 are factors. And I can see that 4 and 5 are also factors. Now, just a quick note, if you're not too sure on how to find factors and use a factor tree like this, go and watch that specific video on this channel. because we're not really going to focus on that today. We're looking at prime factors. Okay, so now I've got my factors of 20. What I'm looking for are the prime factors. But what's a prime number? What does it mean, prime? Well, let's take one of these numbers. Let's take the number 10. And if I had 10, and I also tried to do the factors of 10, I would have 1 and 10, and 2 and 5. So because 10 has a range of different factors, this is not a prime number. Let's look at that compared to the number 5. So when I do the number 5, I can see that my 5 can be made up of 1 times 5, but then I have no other factors. So that means that the number 5 is actually a prime number. So a prime number means a number that has no other factors except the number 1 and itself. Because if you think about it, every number can be multiplied by 1. So in this case, the number 5 is actually a prime number. Let's find other prime numbers of these factors. Well, we know 20 is not, because 20 is the number we started with. Let's look at the number 4. Well, number 4 can be made up of 1 times 4, but it can also be 2 times 2. So because we have this 2 times 2, 4 is not a prime number. And actually, the opposite of prime number is called composite numbers. So 4 is a composite number. What about number 2? If I have 2, I can only make 2 by doing 1 multiplied by 2. So because it only has 1 multiplied by 2, 2 is also a prime number. And now we're left with the number 1. Now 1 is a special number because officially it is not a prime number, even though you could say that 1 can only be made up of doing 1 times 1. But because it only uses 1s and it's got no other number there, officially, mathematically, it's not a prime number. So we need to just remember that 1 is never a prime number. So the prime factors of 20 are 2 and 5. Let's look for the prime factors of 15. Well, 15 can be made up of 1 times 15 and 3 times 5. Well, we know 1 is not a prime number. We also know 15 is not a prime number because that's our original number, and we know that we can multiply 3 times 5 to get 15. We know from our past experience that 5 is a prime number, but let's have a look at the number 3. 3 can only be made up of multiplying 1 times 3. So 3 is also a prime number. So the prime numbers of 15 are 3 and 5. Now I'm not going to tell you all the prime numbers because that's just an easy Google search away, but often it's useful to know the first few. So our first few prime numbers would be 2, 3, 5, 7, 11 and 13. These are often the ones that we'll use the most. But there are loads of prime numbers, just go look for them yourself. Whoa, I'm just going to press pause a second. Have you thought about subscribing to this channel? We put loads of new videos up every week to help you with your maths. So if you're not a subscriber, think about pressing that subscribe button now. Okay, back to the learning. So now let's look at something called prime factorization and understand why it's good to know what the prime numbers of our factors are. Now, prime factorization sounds horrible, doesn't it? But what it means is that we want to break up our factors down to their prime numbers. Let's have a look what that looks like. So if I have the number 32, I could have 1 multiplied by 32. But we know that 1 is that kind of weird prime number where it's not a prime number, but it kind of doesn't fit the normal rules. So let's pick another factor pair. Let's start with 2 and 16. Now if you remember, 2 is our first prime number. So we have a prime number there. But 16 is not a prime number because 16, if we continue the factor tree, can be made up of 2 times 8. Now look, I have a 2, which is a prime number, but an 8, which is not. So I'm going to continue my factor tree, and I can find factors of 8 being 2 and 4. So 2 is a prime number, but 4 is not. So let's continue my factor tree, and I can make 4 by doing 2 times 2. And now look, I have finished because I've got down to 2 prime numbers. So I've used this factor tree to do what's called prime factorization, finding all of the prime numbers. But why is that important? Well, look, if I get my numbers here, 2 times 2 times 2 times 2 times 2 equals 32. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And we can use this skill as we develop our maths knowledge. Now let's use prime factorization to break down the number 45. Well, I can start with any factor pair. So in this case, I'm going to choose 15 multiplied by 3, because 15 times 3 is 45. Now I can see straight away that 3 is a prime number, so I don't need to carry on that side of my factor tree. But 15 is not, because 15 can be made up of 3 times 5. Well, I can see another 3 here, so that must be a prime number. And also my 5 is a prime number, because no other two numbers multiply for 5. So my prime factors of 45 are 3, 5, and 3. Let's check if that works. 3 times 5 is 15. 15 times 3 is 45. So let's look at what to remember. Factors are numbers that multiply together to equal the given number. Prime factors have no other factors but one of themselves, and we can use prime factorization to break a number into its prime numbers. And then the key part is that we can use those prime numbers to multiply back together to get to my original answer. So your turn. I want you to break down the number 75 into its prime factors. Press pause on the video now. Good luck.
Wow, okay, you've done really well if you got this far in the video. If there's anything that's confused you, go back and watch that part again. But if not, let's power through. And now we're going to look at the distributive law. Let's go.
So first of all, let's just think about the word distributive, because it's a bit of a horrible word really. We can think of distributive like distribute or to share out. So what is the distributive property then? So we can look at a question like this first example, 14 times 6. And if we couldn't work out 14 times 6 or we didn't have time to do the written method, what we could do is we could distribute the numbers differently. And we could say that 14 is made up of a 10 and made up of a 4. And if I then multiply those individual numbers still by my 6, I can see I get 10 times 6 is 60 and 4 times 6 is 24. And then with my answer, if I simply add this up, 0 and 4 is 4 and 6 and 2 is 8. And therefore I can get the answer 84. So this can become a very easy method of working out questions mentally. For example, if we have the question 432 times 5, this second example, 432 times 5 is obviously a difficult question to answer, but if I work out quickly what 400 times 5 is, then look at my 30 times 5, and then my 2 times 5, I can do those numbers quite easily in my head. 400 times 5 is 2000, 30 times 5 is 150, and 2 times 5 is 10. And now these numbers are quite easy to add up in my head. I can just add the 2000, the 150 and the 10 to get an answer of 2160. But that's not all that the distributive property is good for. It's also very good for these second two questions, of which this is meant to say 4, of course. So if we look at this first one first of all, 4 times 7 plus 5. I could work this out in the traditional way, using the order of operations and understanding that I need to solve the question inside the bracket first. So 7 plus 5 is 12, and then 4 times 12. And 4 times 12 is 48. Or I can use my new distributive property, and I can understand that in order to do this, I can distribute the 4 and multiply it by the 7. So 4 times 7 is 28, and 4 times 5 is 20. Add these two together, gives me a total of 48. And what you'll notice is it's the same answer in both of those. So the distributive property can be very useful for helping you understand and solve these expressions. Let's have a look at our last one. And again, we can use the order of operations and understand we have to solve the bracket first. 5 multiplied by 9. 5 nines are 45. Or I can use my distributive property and realise that I must first multiply my 5 times 3, which is 15, and then I can multiply 5 times 6 equals 30, plus the 2 together equals 45. And again, same answer. So you can see how the distributive property can be very useful for helping to see the answer to expressions, especially when those expressions can get quite difficult. So there we have it. That is the distributive property within multiplication. Very useful for helping us with mental maths, but also to work out expressions. So what should we remember? Distributive is just a nice way of saying to distribute, or to share out, or move things around differently. Distributive property means to distribute or move the numbers around differently. And we can use this to help with mental maths and solve expressions easily.
Okay, last few parts. We've got multiplying by powers of 10. Let's go.
So what can we remember today? Well, we can remember that we can use a place value chart to help us. So let's begin, and let's look at a very easy one, this opening question, 4 multiplied by 10. Well, what does it mean to use a place value chart to help us? Well, I can simply create a little chart next to where I'm working, and I can have my ones, my tens, and my hundreds. And obviously at the moment I have 4 multiplied by 10, so I'd put 4 in my place value chart as 4 ones. Now when I'm multiplying by 10, what I have to know about my place value chart is that each column is 10 times bigger. So therefore, if I'm multiplying by 10, all I'm going to do is shift this 4 along into the next column, and I have my answer. So my answer is 4 tens, and 4 tens can be written as 40. Now another way to get my 40 is to understand that at the moment in my ones column I have this gap, and to fill the gap I could put a placeholder and then again turns my answer to 40. But like I say, that was an easy start. Let's go a little bit harder. Now let's look at 91.6 multiplied by 10. And as we're looking at powers, let's look at what this 10 represents. 10 could be shown as just being 10 multiplied by 1, or in other words, 10 to the power of 1. So my actual question could read 91.6 multiplied by 10 to the power of 1. But we don't often put the power of 1, we usually start with powers of 2. So again, let's put my 91.6 inside my place value chart, and I would have 9 tens, 1 1, and this time I'm going to need decimal place. So I'm going to have my tenths column and my decimal point. So my decimal point would sit down the line just like that. So 91.6 would look very much like this in my place value chart, and as I'm multiplying it by 10 to the power of 1, all I'm doing is shifting these digits one place again. So I'd have 9 in the hundreds column, 1 in the tens column, and the 6 would jump around the decimal and go into the ones column. Now if I wanted to, I could put my decimal back and my placeholder just to be sure, but my final answer either way is 916. Now we're going to turn up the heat and we're going to look at 10 to the power of 2. What does this little part mean? Now the biggest mistake that can be made at this point is if you just simply put 10 multiplied by 2 and assume that this represents 20. That would be wrong. 10 to the power of 2 means that we are having 10 multiplied by 10. I have 1 10 and I'm multiplying it by another 10. So 10 to the power of 2 means 10 times 10, and 10 times 10 is 100. So I can convert this 10 to the power of 2 into a 100. Now when I put my digits in place, it's 9.45, so I have 9 ones, 4 tenths, and I need another column for my hundredths, and I have 5 hundredths. Now I'm multiplying by 100, I have to understand that each column is worth times 10, so if this is times 10, and then 10 times another 10 would be 100. So 2 jumps is times 100. So I'm going to move my 9 1 2 places, and my 4 1 2 places, and my 5 1 2 places. And again, I could put my decimal and both placeholders in place if I wanted to, but either way, my answer is 945. Now let's look at an orange chili challenge, and let's look at 35.5
35.23 times 1,000. Well, if we're multiplying by 1,000, another way that we could write this as a power is 10 to the power of 3, because 10 times 10 times 10 equals 1,000. So this question is actually 35.23 times 10 to the power of 3. 1, 2, 3 tens. But for us, it's actually easier to look at it as 1,000. So let's put my digits in place. 35.23. Multiplying by 1,000 is going to mean that I'm going 1, 2, 3 jumps. So I'm actually going to need a thousandths column and a 10,000. Running out of space a little bit here, but I'm sure we can make it work. 3 goes 1, 2, 3. My 5 goes 1, 2, 3. My 2, 1, 2, 3. And my 3, 1, 2, 3. Now in this case, I'm going to need my placeholder before the decimal, so my answer is 35,230. Now at this point, we're about halfway. Let's look at a little trick that we can use to try and help us do this quicker without our place value chart. What we should be able to see by now is when we're multiplying by 10, I'm going to be moving my digits one place. When I'm multiplying by 100, I'm moving them 2 places. Times 1,000 is 3 places, and I'm sure you can see the pattern. Well, let's see if we can see something familiar here. Well, if I move it 1 place, it's because there's 1 0 in my 10. 2 places, there's 2 zeros. 3 places, there's 1, 2, 3 zeros, and that pattern would continue. So if I'm multiplying by 1,000, I should automatically know that I'm moving 3 places, and therefore in my mind I can just move everything 3 places and understand that if my 3 is in the tens column right now, then it has to end up in the 10,000s. So I would have 3 10,000s. The 5 is in the ones, so that would move into the thousands, so I'd have 5,000s. 2 is in the tenths, and it would end up in the hundreds. 3 is in the hundredths and would end up in the tens, and I would need something in my ones, so I put a placeholder. And we can see we get the same answer. So let's see if we can do it a bit quicker with the rest of these challenges. And 47 times 100, well, I'm going to be adding 2 zeros essentially. So 47 times 100, or in other words, 10 to the power of 2. 47, 0, 0. I'm just borrowing them from here. So my answer is 4,700. 0.6, bit harder now. 0.6 times 1,000 is going to be moving everything 3 places. So if the 6 is in the tenths column, it's going to be going 1, 2, 3 into the hundreds column. So I have 600. Put back my 2 placeholders. My answer is 600. 9.45 times 10 to the power of 2. 10 to the power of 2, we've just established, is the same as saying 100. 100 has 1, 2 zeros. 9.45, moving everything forward 2 places, is 945. Now we have our first 10 to the power of 3, but it's no harder. All it means is 10 times 10 times 10, which is 1,000. So we know this 10 to the power of 3 is 1,000. And if at the moment my 3 is in the ones column, I need to move them 1, 2, 3 places. So it's going to come 1, 2, 3 into the thousands. So I have 3 thousandths, fill everything else in. My 5 would come next. Then I have 2 gaps before my decimal, which I need to fill with placeholders. 3,500. Simple. Now it's your turn. Have a go at these 3 challenges and see if you can work out the answers to these. Put your answers in the comment section. I'm going to try and mark every single one. Press pause on the video now. Good luck.
Wow, here we are, our last lesson. You've done super well to get here, but let's finish on a high. Let's have a look at how to divide by powers of 10. Here we go.
So what are we going to remember today? Well, we're going to remember that we can use a place value chart to help us. So let's have a look what that means with our first question, 48 divided by 10. Well, we're starting off nice and easy because 10 is simply just 10 to the power of 1, so we don't have to do any other multiplication or calculation. All we're going to use is our place value grid to help us understand how to do this division. So first let's build a place value chart, and I'm ready to begin. So my question was 48 divided by 10. So first let's put our numbers in place. 48 is 4 tens and 8 ones. And if I'm dividing by 10, what I have to realize is that every column on my place value chart is 10 times smaller than the column in front of it. So essentially we are dividing by 10 as we come down the place value chart. So if we think about it, one jump would be dividing by 10, but if we made 2 jumps, I'd be dividing by 100. 3 jumps dividing by 1000, and so on and so on, but we'll get to that in a moment. For now, we realize that we're only dividing by 10, which means we're going to be jumping 1 column down my place value chart. So let's begin. And my 8 will come into my 10th column, and my 4 into the ones column. Put back my decimal, and I'm left with 4.8. One thing to make a note of, my decimal place never moves. We consider it like a nail in the wall. So 48 divided by 10 equals 4.8. Next one, 91.6 divided by 10, a little bit harder. Let's have a look. We have 91.6 divided by 10. Put the numbers in place, 9 tens, 1 1, a decimal, and then 6 tenths. And we're dividing by 10, so exactly the same thing. I just moved them to one place down my place value chart. And once I put my decimal point back, I'm left with 9.16. Now we're starting to get a little bit harder because I have 9.45 divided by 10 to the power of 2. So what does that mean? Well, a very common mistake would be to do 10 times 2, which is 20, and assume that this 10 to the power of 2 is 20. That would be wrong. 10 to the power of 2 means that we have 10 multiplied by 10, or in other words, 2 tens multiplied together. So if we think about it, if it was 10 to the power of 3, I would have 3 tens multiplied together, and 10 to the power of 4, 4 tens, etc., etc. So 10 to the power of 2 is 10 times 10, which equals 100. So my question is actually 9.45 divided by 100. So first job again, let's just put our numbers in place. 9.45 is 9 ones, decimal 4 tenths, 5 100ths. And because I'm dividing now by 100, it means that I'm going not just one jump, that would be divided by 10, but 2 jumps. So I'm dividing by 100. So if we're jumping twice, I'm going to need another column here as my 10,000. And here we go, let's start moving numbers. My 5 100ths become 5 1000ths. My 4 tenths become 4 thousandths. My 9 ones become 900ths. And now you can see if I put my decimal, I have this gap again, which I need to fill with a placeholder. So my answer would become 0.0945 or 0.0945. Okay, let's look at an orange chili now, and I have 352.3 divided by 1,000. And my 1,000 could also be written as 10 to the power of 3. Because remember, 10 to the power of 3 means 10 times 10, which is 100, times another 10, which equals 1,000. But actually for us, 1,000 is easier to use, so we'll keep it as 1,000. And now because I'm dividing by 1,000, I'm going to need to move 1, 2, 3 places, because that would be divided by 1,000. And again, it all kind of links in, doesn't it? Because 10 to the power of 3 equals 1,000. So therefore, if we're dividing by 10 to the power of 3, I'm dividing by 3 of these columns because each column is worth a power of 10. Okay, so let's put our numbers in place, 352.3, and I'm dividing now by 1,000, so I need to move them 3 places. So my 3 would come 1, 2, 3, my 2 is 1, 2, 3, my 5 is 1, 2, 3, my 3 is 1, 2, 3, put back my decimal, put a placeholder there in front of it if I want to leave me with 0.3523, or I could get rid of that 0 and just call it 0.3523. Okay, let's look for a pattern now as we get into these final 4 questions. Hopefully what we're seeing now is that if my question is dividing by 10 to the power of 1, I'm moving my digits 1 place. If my question is 10 to the power of 2, I'm moving them 2 places, because that's like saying divided by 100. If it's 10 to the power of 3, or in other words, divided by 1,000, I'm moving them 3 places. So using that knowledge, let's see if we can answer these last 4 without using the place value chart and just using knowledge in our heads. So 47 divided by 100 would be 47 moved 2 places. So my 4 would go from being in the tens column to being in the tenths column. So I would have 0.47 as my answer. Next orange chili challenge, 873 divided by 1000, or in other words 10 to the power of 3. So I know I'm going to be moving them 3 columns. So if my 8 is in the hundreds column, 3 columns to the right would be the tenths column. So I'm going to have 0.873 as my answer. 10 to the power of 2 means I'm going to be moving 2 places, and the 1 in my tens column will therefore be in my tenths column. So again, 0.1945 would be my answer. And finally, the last challenge, 10 to the power of 3, we know means I'm moving 3 places. So if my 3 is at the moment in my ones column, 3 places down my place value chart is in the thousandths column. So I can put my 3 in the thousandths, my 5 in the 10,000ths, but then I'm going to need a placeholder in my hundredths and a placeholder in my tenths, put back my decimal, put a 0 in front of it if I want, and my answer is 0.0035. These challenges here might be a little stretch for you at the moment, but once we fully understand our place value chart and how it works and the column titles, you should be able to do questions like that in your head. But I recommend always checking on the place value chart. Here you go then, it's your turn. Here are 3 questions for you to work out. Use the place value chart if you want, or have a go at answering these in your head. Press pause on the video now, good luck.
And there you have it. That was everything you need to know about Year 7 number. If you've mastered this, you are going to be an absolute legend in your maths class. But remember, this is only the first unit of a group of units that are coming up. So to find those lessons, head on over to themathshelter.com or have a look on this YouTube channel for the rest of these lesson series. But for now, guys, I'm going to see you in another video. Peace out.